Okay, so in this video we will talk about Lex's theorem, and that talks about the convergence of a scheme or convergence of a discretization procedure. So the first definition that comes in Lex's theorem is the consistency. And what do we mean by consistency in terms of discretized equations? That if the limit of delta t tends to 0, then the difference form of equation will approach to differential form. What does that mean? That hn plus 1 minus hn divided by delta t limit delta t tends to 0 should approach dh by dt. That means difference form or the finite difference equation should approach differential equation, that is ODE or PDE, as delta t tends to 0. So this is what we mean consistency. The next definition that comes in theorem is stability. Stability means repetitive calculation will not diverge. That means repetitive evaluation of discretized equation should not diverge. That means we will get an expression for hn plus 1 in the form of hn plus delta t f of either t to the power n or h of n plus del t f of t to the power n plus 1. So the repetitive application of this formula to compute hn plus 1 should not diverge, and that is called stability. So what does Lex's theorem says? That if we have consistency plus stability, then my equation will definitely converge, or we will have convergence as delta t tends to 0. That means my solution error, which is exact minus approximate value, will tend to 0. So having said this, according to this Lex's theorem, we find that implicit methods are unconditionally fulfill the Lex's theorem criteria, while explicit methods conditionally satisfy the Lexis theorem. So we will see how I am making these two statements. So let us see that. So now we are studying about the convergence and stability of explicit and implicit formulation. So we will understand this thing with one example, that is dH over dt plus CH is 0. So let us do the explicit discretization. So the explicit discretization says that h at n plus 1 minus h at n divided by delta t is nothing but minus c h n. This implies that h n plus 1 is nothing but 1 minus c delta t h n. So this equation, this to converge, we should have 1 minus c delta t greater than 0. That means delta t should be less than 1 by c. So if delta t of this discretized equation is less than 1 upon c, then only this explicit formulation will converge. So I am saying that explicit methods are conditionally stable and they only converge when delta t is less than 1 by c. If delta t is greater than 1 by c, then solution either diverge or oscillates. So in most of the cases delta t is taken as 0.1 times 1 by c or 0.1 times tau. This 1 by c is called, so here this dH by dt plus CH is equal to 0. This delta t is less than 0.1 1 by c or 0.1 times tau for explicit methods. If we take delta t as this, then our explicit method will definitely converge. So let me put chargers on my laptop so that this continue working, and let me insert my charger here. Now we have seen that explicit methods are conditionally stable or they conditionally converge. Let us go to implicit. Method. So my ODE is dH over dt plus CH is equal to 0. So this we will talk in the next video.